All right, I'm Graham. I'm here to talk about a small hobby project I've done recently, which is NixOS on the DGX Spark. So what is the DGX Spark? Well, it's one of these guys. It's an NVIDIA desktop sort of AI workstation. It's got a GB10 GPU in it, so a Blackwell era GPU, which is relatively up-to-date and quite powerful. It's got 20 ARM cores. And it has 128 gigs of unified memory. So the cool thing about this is you can use it as CPU memory or GPU memory, and you can, you can use if you're not using it as CPU memory, you can use it all as GPU memory, which is quite useful. So by default, it comes with this NVIDIA DGX OS, which is an Ubuntu derivative, but we want NixOS, obviously. Okay, so how do we get NixOS? Well, this is a short talk, so just to cut a long story short, I got it working. And there's a repo here, so you can look at it if you want. But basically, it's got a flake in it. It has an output that builds a USB boot image. It has a NixOS module that you can include in your config. And it also has a template, so you can make your own NixOS config if you want. Sorry, my headset's falling off. I guess the main difficult part was building this custom NVIDIA kernel. So NVIDIA has their own GitHub repo with their own kernel fork with a load of config options. So you need to do that, and so I've got that working. And it also does all the various drivers and NixOS options to make it work. And it also supports this thing called DGX Spark playbooks, which is actually the main thing I want to talk about in this talk. So what are DGX Spark playbooks? Well, they're these kind of recipe things that you let you do kind of cool things on your DGX Spark. So things like run a VLLM instance to serve an LLM, or fine-tune a model in PyTorch, or generate images with Comfy UI, that kind of thing. So there's a lot of good stuff there. There's a lot of interesting things to play with. But there is a problem. What is the problem? So warning, there's a bit of disturbing content coming up, at least for this audience. So yeah, look away now. So the problem with the playbooks is that they basically have a lot of things like this. So they're like, oh, check all your prerequisites. So what versions of stuff do you have? Or install this VM with pip. Or install this other thing with UV. Or set all these environment variables, make this directory, chmod this thing, run this container. It's all kind of complicated. Or download this random stuff off the internet. Or run this stuff off the internet. Et cetera, et cetera. So not very nice if you're in a Nix kind of world, right? Also, it's not only the playbook. So on the forums, there's lots of like, oh, I tried to install this thing, it doesn't work. Here's my recipe for getting this thing to work, which is like 5 pages long. Here's another one, here's another one. So there's a lot of work going into this. It's not ideal, right? So obviously this is PlanetNix, so we know a better way. And the better way is to use Nix. So in this repo that I mentioned before, we've got a flake, and it exports some dev shells and some apps, which are basically the equivalent of these playbooks. So to run the VLLM one, all you do is nix develop .hash VLLM, or the Comfy UI one, very similar. So it's they're all defined in the flake. They're using packages from Nix packages and also Nixify.ai, which is quite a nice project for this kind of stuff. There's one command to run them and set them up. And everyone gets the exact same thing, right, which is the beauty of Nix. So that's much better, in my opinion. So in terms of pros and cons for Nix, or advantages and disadvantages, so on the plus side, I think the thing I found which I was surprised at is the Nix packages CUDA ARM ecosystem is actually pretty healthy, and I didn't have to do that much to fix things to get it all the stuff to work. Building the custom kernel for NVIDIA is actually quite easy as well with NixOS. This write once works for everyone thing is obviously a big thing with this kind of use case. And flakes are actually a really good interface for this because you can export them as apps and dev shells, and you can easily introspect what's available, and it works really well. In terms of rough edges, I think you can't really get cached CUDA builds of ARM stuff at the moment. We would like to fix that. A lot of us are working on that. I think we'll fix that at some point. The freshness of packages is a bit uneven. Some things are quite up to date, some things are quite old, and you have to sort of hack it around. I think ARM Linux is actually not the most used sort of target, so some things are just broken, but actually not that much, really. And we don't have any test hardware for the community with GPUs like this one, like an ARM attached GPU. So I think the main thing I wanted to say in this talk is not really about how I got this working, but it's that there's an opportunity. So I think shipping an AI package ecosystem like this is really difficult. There's a huge amount of stuff in it. They all don't work together very well. It's really hard to make it work. But Nix is actually really good at this. And so this DGX Spark is actually a really good use case, I'd say, for Nix. Like if we were to use Nix flakes and expressions instead of those recipes, I think everyone would have a much better time. Because they're reproducible, they hide all the complexity, the out-of-the-box experience for the users is much better, the support burden is much lower for, you don't really have these reproducibility problems anymore. So I guess my pitch, if there's any, I don't know if there's any video folks in the room, but I really think they should use this. Yeah, and that's it, thanks. And thanks especially to the Nix CUDA team.